Hi viewers, it's me Satya from Shutterpix.in. Today we are going to look at fundamentals of Lightroom tone curve. If you are expecting any quick tips or hacks, then this video is not for you. You can stop right away. In this video, let's understand how the tone curve works and how we have to make manipulations to get the results that we expect. Come on, let's get into the video. We will use this 5 image to understand how tone curve works. They are extreme examples handpicked to demonstrate its power. Let's start with the first image. Let's go to the develop module. Since we will be working on the tone curve, I closed rest of the controls. And here we have to pay attention to two things. The histogram at the top and the histogram that is shown within the tone curve. Tone curve have 5 modes. The most prominent is a point curve mode where we could have points anywhere in the control and then move them up and down to adjust the image. The second one is parametric curve where the points are predefined or preset based on mid-tone shadows and highlights, and we could adjust them as we wish. Okay, the curve can also be adjusted using the sliders provided here. They basically adjust the pointers there. And if you want to adjust our definition of shadows, midtone, and highlights, we could adjust this points here to adjust where those control points occurs. And we also have three other modes, channel modes, red channel and green and blue channels. Instead of impacting the exposure, the curve here impact the strength of the color within that range. Okay. Here in the red channel, the top portion is red and bottom portion is green. We can visually see them. Similarly, in green, it is green and magenta, and in blue channel, it is blue and yellow. Okay. Let's start with this point curve. We'll reset the image. When we move our cursor around here, you could see the input output value changes. Let's understand what is that and how this tone curve works with the visual. X-axis represents the input and Y-axis represents the output. Both of them can take a value between 0 to 255. Why? We know images are formed by pixels and each pixel is contributed by 3 channels RGB which forms the color image. And each of this individual element takes a value between 0 to 255, whereas 0 means extreme dark and 255 means extreme bright. Let's get back to our graph. For a tone curve like this, how to compute the output? Let's assume our input pixel value is 150. Start drawing a vertical line from the x-axis at the 150 point. Wherever it meets the curve, stop there and then start drawing a horizontal line. Wherever this horizontal line meets the y-axis, this is the output. In our case, it's 220, roughly 220. Let's pick one more example. For an input pixel value of 100, draw the vertical line. It meets the curve. Now start drawing the horizontal line. It meets the y-axis at 170. So input pixel value of 100 is mapped to a pixel value of 170 in the output. Similarly, let's do for 200. For a 200 input pixel value, it gets mapped to an output pixel value of roughly 250. Similarly, perform such transformation for all the pixels in our image, then we would be getting the output image. Have you ever wondered why we have a 45-degree line as a default tone curve? Because this is an identity map function where input is directly copied to the output. When the input pixel value is 150, when we map it using the curve, 45-degree line, output is also exactly 150. The same is true for other pixel values like 100, 200 and every number that ranges from 0 to 255. Assume we have a curve like this. What happens then? Before attempting to answer, let's experiment this in the Lightroom. Let's make this curve flat as we have seen earlier by pushing up this pointer to around 128 and pushing down this pointer to exactly equal to the same value, making it a flat curve. All we see is a gray image. That's because here, whatever may be the input, all inputs are mapped to the same output value of this 127. By moving this line, we could get a different values of gray. As we move towards the upper direction, we get a brighter gray, and by moving closer to the bottom, we get a dark gray. In a sense, we are losing all the information, and whatever may be the input pixel, they are mapped to exactly same value. If you are paying keen attention, you might have noticed one more thing. The histogram at the top is getting updated as we change the tone curve. Let's do one more time. Here, if you see, we are changing the curve, and this histogram is getting impacted, but not the one behind the tone curve. This is because the histogram at the top represents the final output histogram, final output image, and the histogram in the tone curve represent the input images histogram. Okay, what do we call as input image? So that is the input image that is received before any of the tone curve changes. Let's say if you want to impact the input tone curve, for a moment, let's go to the basic panel and adjust the exposure. Let's say we move this exposure a bit. Now you see input to the tone curve is updated. As we make changes to the tone curve now, we are working on the updated input. This also leads to another interesting observation. When we have a flat curve, even though changing the exposure doesn't impact the final output histogram, that's because since this is a non-destructive editing and then the final output that we get is combination of all of them. In the tone curve, we set a flat profile. It doesn't impact whatever may be the input. Always we are getting the same output and then like the final output remains same. Come, let's go to the second example. In this image, we want to make the background as a perfect white to make it look beautiful product photography. We also want to remove the wrinkles. If we look in terms of the pixel values, probably the background white is not a perfect white right now, but it might have a very high pixel value. If we look at this histogram, it feels like they take a value between 210 or 220 something. And how to make this as a perfect white? One way is just grab this one pointer and then move it left. As we move, you can notice that like background is getting brighter and brighter. Yeah, now we achieve the results that we expected. This is because in this particular setting, we retain all the pixel values that ranges from let's say 0 to 220. That's where we see this image of the sari and then patterns within it. But after that point, let's say in this case it is 195. After that 195 mark, everything is pure white, 255. The same result could have been achieved with one more technique. Let's say we could add one more pointer here and then push that value towards the max 255 level. Even in this case, we achieve the same result. But there is a subtle difference here. If you notice, in this setting, the second way of achieving the results, we not only brighten the background, we also brighten the input image, the sari subject here. That's because the curve is somewhat moved towards the top left corner. Just to compare this result with the previous result, let's move few steps in the history. And this is a previous way of achieving the result. And this is a new way, adding a 3-point method. You can see subtle difference here. The subject became a little bit brighter. The choice is ours. We can use any one of the technique to reach this result, and it might change based on the subject and then lighting conditions. Let's move to the next image. Here, I want to darken the region behind the leaf. We can use the same technique we did earlier. We made near white as pure white by dragging this point here. We are going to do something similar here by dragging the point at the lower bottom. By moving it right, we made the near black region as pure black, and then it adds a very good contrast. Here, if you look, there is a dark region and then bright green leaf. I just got a wild thought. What if we change the curve like this? Now we have fair understanding of how turn curve works, so we can make a guess. Here, 0 input is mapped to an output of 255, and input of 255 is mapped to 0, and everything linearly in between. Basically, this turns black as white and white as black. So the output image is going to be negative of the original image. Let's make the change and see the result for ourselves. Moving this pointer to the top left and moving this pointer to the bottom right. Yeah, wow. Now we are seeing the negative image as we guessed. Let's go to next example. This is an overexposed image. The task here is to recover it using the tone curve. Let's enable the clipping highlights. Yeah, we see a lot of highlight clipping with a red marker here. One technique we could use is to rescale this image. Drag the pointer in the bottom left towards right and say we are recovering the image nicely. Say at this point, most of the image is recovered, like a lot of highlights got recovered. No, we don't see any of the highlight clipping except some points here. What we effectively did is that 0 to 125 of the input image is made as 0 and the rest of the image 125 to 255 is remapped to 0 to 255. We just basically rescaled the input image. This technique led to another problem. We see a lot of shadow clippings here, meaning there were some information at this portion 0 to 125 that got lost in this way. There is an alternate technique we can do. Let me undo this movement. Initially we want to recover the highlights, so we add a pointer here and bring it down as much as we want. Yeah, did it nicely. We recover the highlights. Again, similar to the old way, we added some shadow clippings. To address that, we can add one more pointer here and then bring it up a bit. So we retain both the shadows as well as highlights and it got recovered nicely. To further enhance this image, we can bring down the whites and highlights. Let me play with whites a bit. We brought down the whites and then similarly we can bring down the highlights also. Let's enable comparison view. If you see, this image is much better than the input image and here we can see a lot of information there. In the original input image it's kind of all pure white. Now we see patterns, textures here. Of course this is a faded blue roof. Let's move to next example. Let's come out of this comparison view and then disable the highlight warning. The task here is to apply S-curve and make it more contrasty. If you are using Lightroom, you must be familiar. To apply S-curve, we have a point at the middle and then we push up the highlights and then we add one more point here and then bring down the shadows. It feels like we lost some contrast. Let's go to the comparison view. Yeah, it's true. So input image seems to be having better contrast than the after applying S-curve. What happened here? So when applying S-curve or any modification, we have to remember the input to output mapping that we did. So in this specific image, it's kind of again an exposed to the right image where most of the information lies in the right. And if you look, the right portion of it, highlight portion of it, we increased. So the complete image is highlight and then we increase its exposure further, losing our contrast. So in this case, what we have to do is, like, we'll reset the image. Within this distribution, we have to increase the highlights and bring down the shadows. Not exactly shadow, but like the lower exposed region. Let's add a point here and then bring it up. Let's add one more point here and bring that down. Now we can clearly see a nice recovered image. We see a lot of cloud. I think we can play a little more to bring it down. Yeah, okay, this is nicely recovered image. So we can add a little more drama by doing a color grading on the highlights. Like we can bring up the we have a little bit of blue there. And then further, if you want to bring down the exposure, we might even make it as a rain clouds. Little bit of exposure adjustment made it look like a rain cloud. The takeaway in this image is that S curve or any curve, its shape doesn't matter. It's applicable only to the input histogram that's shown behind the tone curve, and we have to keep that in mind before making any alterations here. What are the don'ts in a tone curve? One big no-no is the right side of the tone curve should never be lower than the left side. Let me show what I mean. Let's bring that up and then bring this down. So now if we see input value of roughly, let's say, sorry, input value of 60 is mapped to output of 100, whereas input value of 150 is mapped to 60. So higher input value is mapped to a lower output value. This should never occur in your curve. Whatever maybe, if it's specifically for specific artistic look, it's okay, but don't do it generally, because this kind of brings in a negative effect that we had seen in the leaf example. For this specific segment, it became a negative. Hope you find this video useful. If so, give a like and subscribe to see many such videos. If you have any questions or thoughts about Lightroom tone curve, share them in the comments. I will try to answer. Let's connect in another video. Bye.